Welcome to another awesome edition of Comet Algebra. This video is for Algebra 1, Chapter 4, Section 4, Conjunctions. So in math, especially with inequalities, we can make compound sentences where we put two inequalities together. And we can put them together two different ways. We can use the word and, or we could use the word or. And these are very connected to things that we studied in Chapter 1, so we're going to try to connect it back to your previous knowledge. Compound sentences that use the word or are called disjunctions, and we'll be looking at them in the next section, in 4.5. Today in 4.4, we're going to look at what's called conjunctions. And I know and is called a conjunction in English class, so it's kind of similar to that. And in English, or is also called a conjunction, but we don't call it that in math, so it's different. So the definition of conjunction, it's a compound sentence with the word and. In order for a conjunction to be true in math class, both parts must be true. What this could look like, an example of a conjunction, could be the statement that x is less than 3 and x is greater than -1. It has to be true for both of these in order to be a solution here. So for instance, 7 is not a solution because it's not less than 3. It is greater than -1, but it has to satisfy both at the same time. So a conjunction is very similar to when we studied the intersection from Chapter 1, where we found the overlap, which satisfies both statements at the same time. And just so you know, this is what the conjunction symbol looks like. And to help you remember it, I think it sort of looks like the part of a capital A for and so it's conjunction, and it's connected with the word and. Please note that it's like an intersection, and we'll look at how to combine these into one inequality. I would just like to remind you, when you have an inequality with less than or equal or greater than or equal, we use a closed circle. And if it's just greater or less, we use an open circle. And the other thing I'd like to remind you of, when you're solving an inequality, if you multiply or divide both sides by a negative, you have to flip the inequality sign. So our first example is asking us to solve and graph the solution set where we have 2x plus 5 is less than or equal to 11, and I'll just put both here, the word and the symbol, and -3x is greater than 18. Now we can't even see this yet until we solve these, so we use the undoing method to solve. So first here we subtract a 5 from both sides, and I get 2x is less than or equal to 6, and when I divide both sides by 2, I get x is less than or equal to 3. So that's the first part of my compound sentence here, and I'm going to keep the word and here. And to solve this other part, we have to divide both sides by -3, and I hope you realize that when you divide by a negative, we need to flip this inequality. So we need to say and x is less than -6. So now to help us see the solution, we're going to graph these both on a number line and see where the two graphs intersect, or where they overlap, or where the solutions satisfy both of them at the same time. So I'm going to graph this first inequality, and I'm going to use the color red. So if x is less than or equal to 3, we need a closed circle on the 3, and less than would be an arrow going to the left. Now let's graph the other one, the other inequality, in blue. If x is less than -6, we need an open circle on -6, and less than is arrow going to the left. So now we look at the overlap. Which solutions on this number line satisfy both at the same time? Well, if you'll notice, right, starting here, not including -6, and everything going this way, satisfies both of these solutions at once. So I'm going to graph that in black right on the number line. So the solution is not including -6, but everything going smaller than that. So we also need to be able to not just show this on a graph, but we need to state this as an inequality. So the answer to both of these together is this part that I graphed in black. It does not include 6, but it includes everything smaller than that, which would be x is less than negative 6. So this is how we state the solution in an inequality sentence, and this graph is how we show the solution on a graph. All right, let's do example 2, where again we're asked to solve and graph the solution set of this inequality, and we're supposed to state the solution as an inequality. So let's try to get used to working with 3 parts of this at once. So we're going to solve for this x. We want x alone here in the middle. So the first thing we're going to do is subtract a 5 from the middle, subtract a 5 from the right, and subtract a 5 from the left. And if you keep it all together like this, you're saving yourself a lot of work. So I hope this isn't too weird for you. So over here on the left, we get negative 6 is less than 3x is less than 3. And again, we want x by itself, so we're going to divide everything by 3. This becomes negative 2 is less than x is less than 1. So this is something we can graph now. We have an open circle on negative 2. We have an open circle on positive 1. And negative 2 is less than x. That means that x is more than negative 2, but at the very same time, x is less than 1. So in other words, it's in between these. So I'll just kind of color in this graph with red. This is x being more than negative 2, but less than positive 1. And to write that solution as an inequality, since we kept this as an inequality, instead of figuring it out from the graph, I think that saved us some work. Whoops, that's just a 1. So we read that negative 2 is less than x is less than 1. That's the solution. All right, the instructions for number 3 are the same, solve and graph. But in example 2, we kept it to the 3 parts together because the steps were the same. We, subtracted a 5 from everything and divided everything by 3. However, example 3 is different because we have these 2 x's here. We can't keep this all together. So we're going to split it up into 2 parts and connect them with the word and solve them separately. So here's what that looks like. You just write x minus 3 less than or equal to 2x minus 9, and then we just put the right side, 2x minus 9 is less than 15, and go ahead and solve these separately using the undoing method. So here we'll subtract a 2x from both sides, and we will add a 3 to both sides. So I hope that's okay. I'm doing 2 steps at once. So I end up with negative x less than or equal to a negative 6. And of course, we have to divide both sides by that negative 1. So, and of course, flip the inequality. So x is greater than or equal to 6. So that's the first part of my conjunction. And then I have to come over here and I'm going to add a 9 to both sides, which gives me 2x less than 24. Divide by 2, I get x less than 12. So these are the 2 parts of this conjunction that we are going to put on the number line. So let's graph this first part, x greater than or equal to 6. We'll graph that in red. So if it's greater or equal, we need a closed circle, and greater is an arrow going to the right. Now I'm going to graph this other part in blue, this x less than 12. So let's come over here. Less than means an open circle over the 12, and less than would be going to the left. So and, remember, and is asking you where is the intersection. So you look at what satisfies both of these at the same time, and I'll put that in black here on the number line. So this right here, including the 6, so we fill in the circle, And right here, not including the 12, that's an open circle, but everything in between is the solution that we're looking for. And so now, from the number line, we can state this as an inequality. The lower bound, the lower number, is 6, and this is a closed circle. So a 6 is less than or equal to x, and x is smaller than 12, but does not include 12 because of the open circle, we have a less than sign. So we can also do it this way and take the inequality off of the graph. All right, now you have the information you need to do section 4.4, so have fun with math.